Hello, this is Geometry, Topic 8-1 over Inscribed Angles. First, let's talk about what an inscribed angle is. An inscribed angle is when you have a circle, you have an angle that's inside the circle, and the vertex is on the circle. So, an angle whose vertex is on the circle and whose sides are both chords of the circle. This is an inscribed angle. So we're going to start off by naming some inscribed angles. Well, I have angle DOG and angle DOG inscribes or creates, intercepts arc DG. So it was DOG. Now I've got OGD. And OGD intercepts arc OD. Now I've got GDO, and GDO inscribes arc GO. Notice that when we're inscribing an arc, it's the legs of our angle that make the arc. So that's how we name the inscribed arcs, and that tells us which arc we're intercepting. The reason for that is this theorem. If an angle is inscribed in a circle, then the measure of the arc is half the measure of the intercepted arc, which is this formula right here. Now we're going to go ahead and use this formula in example number 2. So, we're given that BC is 100 degrees, and we want to find out what X is. Well, looking at this, I need to find some kind of relationship between this arc and this arc. Well, I know that this is a diameter, so that means that the arc here, ABC, is a semicircle at 180 degrees. Well, if BC is 100, I do 180 minus 100, and I get that this is 80 degrees. And my inscribed angle is half of the arc, so 80 over 2 is 40. So X is 40 degrees. You could also think of that as the arc is twice the inscribed angle. Now we do have another theorem. This theorem says that if two inscribed angles of a circle are congruent circles intercept congruent arcs or the same arc, then the angles are congruent. So basically, congruent angles mean congruent arcs. Let's go ahead and put that into practice for example number 3. We're looking at ST is 68 degrees, and I want to find the measure of angle 1 and the measure of angle 2. Well, angle 1 has arc ST. I'm actually going to go ahead and go over that with a blue pen. We're looking at arc ST. So half of 68 is 34. So measure of angle 1 is 34 degrees. I'm going to switch to an orange pen because angle 2 is also arc ST. So it's also half of 68, so it is also 34 degrees. Okay? Because these angles have the same intercepted arc, they are the same measure. Okay? Now, if it was just congruent arcs, we would know the angles are congruent. And if it was congruent angles, we would know that the arcs are congruent. Our next theorem says that if an inscribed angle of a circle intercepts a semicircle, then the angle is a right angle. So, for example number 4, because this is the diameter, so this intercepts a semicircle. This intercepts FHG. It's 180 degrees. Since it intercepts this, that means that this must be 90. Let's put some of this together for example number 5. So here we have circle A, and it gives us a bunch of measures. It says the measure of angle 1 is 6x plus 11. The measure of angle 2 is 9x plus 19. Measure of angle 3 is 4y minus 25. And our angle 4 is 3y minus 9. It also tells us that arc PQ is the same as arc RS. And we want to find some of this stuff out. So, we're looking at this, and if this is 6x plus 11, this must be half of that. This is R9 plus 19. It must be half of this. And I could work with that. However, I'm looking back at the theorem we just talked about. These intercept a semicircle, which means that this is a 90 degree angle. And I know this is a 90 degree angle. There are 180 degrees in a triangle, which is what I have. So, 6x plus 11 plus 9x plus 19 plus 90 must equal 180. Well, 6 plus 9 is 15x plus 11, 19, and 90. When we add those together, we get 120. That equals 180. We subtract 120, and we get that 15x equals 60. Divide by 15, and we get that x equals 4. So if x equals 4, and angle 1 is 6x plus 11, 6 times 4 plus 11 is 35. And 9 times 4 plus 19 equals 55, which is angle 2. Now to find 3 and 4, well, I have angle 3 is arc PQ. Angle 4 is arc RS. These are congruent arcs, which means that these are congruent angles. So 3y minus 9 equals 4y minus 25. Move my y's to the same side. Negative 9 equals y minus 25. Add 25. 16 equals y. So, plug that back in. 4 times 16 minus 25 is 39 degrees. And 3 times 16 minus 9 is also 39 degrees. And we've already said that these are equal, so we're hoping that we get equal answers here. So just to break it down, measure of angle 1 and 2, we use back to the theorem that if I intersect a semicircle, I create a right angle. And to find 3 and 4, we went back to the fact that if the chords are congruent, the angles are congruent. Let's take a look at example number 6. But first we have a new theorem. The quadrilateral is inscribed in a circle, then its opposite angles are supplementary. Supplementary means they add to 180. So, we look at this. QRST is obviously a quadrilateral, and it's inscribed inside circle C. Well, T is 95, and S is 100. I'm going to go ahead and call this R and that Q. Well, opposite angles mean that 95 plus R equals 180, and 100 plus Q equals 180. So R must be 180 minus 95, which is 85, and Q must be 80, because 180 minus 100 just gives us 80. So measure of angle Q, 80 degrees. Measure of angle R, 85 degrees. On to example number 7. We want to find the value of the inscribed angle. We have to go back to our previous unit, that would be unit 7, where we said that the arc is equal to a central angle. Well, if this central angle is 90, that means that the arc is 90. If the arc is 90, the inscribed angle is 1/2 of 90, which is 45 degrees. Now moving on to number 8. This is 120. This is 3x minus 3. So 3x minus 3 equals 1/2 of 120. Well, 3x minus 3 equals 60. 3x equals 63. X is therefore 21. Hopefully you followed along with that algebra. We've done enough of it that you should be able to follow those simple steps. Moving on to example number 9. Last example. Here we have a hexagon inscribed inside a circle. All the sides are congruent. Now, if the sides are congruent, that means that this chord is congruent to that chord. So this arc is congruent to that arc. So all of our arcs are congruent. Well, there are 360 degrees in a circle, and there are 1, 2, 3, 4, 5, 6 sides. So 360 divided by 6 gives us 60-degree angles per arc. So arc CD would be 60 degrees. Now angle CFE encompasses 2 of these. So we need 1/2 of 60 plus 60, which is just 60 degrees. Now, angle BCD well, that would be 1, starting from here, going to there, 1, 2, 3, 4 of these chords. So 1/2 of 4 times 60. Well, that's 120. And so this is 120 degrees. And that's what we're talking about. So there were lots of theorems that we talked about dealing with inscribed angles and arcs. Please keep your notes and make sure you're reviewing back to your theorems if you forget. look at your examples as you're working on your assignment. If you do that, it shouldn't be too terribly hard. Good luck and have a good day.